All right, so as we look at these free responses for inference for means, we have a packing company considering hiring a national training consultant. Okay, he's going to help them improve their packing capabilities. And so the training, they're taking 18 employees, so that's less than 10% of their group, and they randomly selected them, I'm sure, probably, maybe not. Be implemented if the average increases by more than 10 cases per day per employee. They're going to use an alpha of 0.05. So the null hypothesis is that mu will equal an increase of 10 cases per day. The mu equals an increase of 10 cases per day, because that's what it's talking about. Increases by more than 10 is our alternative. The alternative is the mu is greater than an increase of 10 cases per day. And then if we look at the type of errors, the type 1 error, rejecting the null hypothesis, rejecting the null, as opposed to a type 2 where we fail to reject, which would be worse. In this case, it would be a type 1. A type 1 error because the training is thought to improve productivity, and it doesn't. They implement the program for improving productivity, but is a total waste of time, money, and manpower, or person power, whatever you want to write. Okay, and then we're talking about inconclusive results. The manager decided to test the training program with another group. Okay, 2 changes he could make. He could, 1, increase sample size. Which costs more money and time. Or 2, he could, he wants to increase the power of the test. He could raise the alpha, which may lead to a better chance of a type 1 error. Okay, so there are those 3 parts. Our mu's, type 1 error. To change the power, increase the power, you can increase the sample size or raise your alpha. Okay, down here on the flights at the bottom of the page, so they fly people in from all over the nation for the AP exam to grade it, and they took 10 vouchers from the East Coast and the West Coast. They were random samples. Okay, and the cost in dollars is shown on the table. Indicate what inference procedure you would use. Well, it would be a 2-sample t-test because we have 2 different samples. And then we're going to decide if we should actually perform that test. So we check the appropriate assumptions and conditions, and a lot of you got confused by that word assumptions. We're going to assume that they're independent, and that's the assumption. So when you have 2 groups and a 2-sample t-test, there are 4 things we have to do. And so that first one there is, are the groups independent of each other? And we can assume that those 2 are independent of each other. Then we looked at it, said it's a random sample of the vouchers. And we know that 10, each of these 10s, are less than 10% of all the flights from each coast. So then that leads us to our histograms. So put this in L1, ran the histogram. This one wasn't bad. This one lined up kind of nicely. As a matter of fact, it was almost perfect. But then this is from the East Coast. From the West Coast, not so much. 5 of the nut values were in this bar. Okay, 5 of them were in this bar. So half of them. And there's no way in the world we can manipulate this so that we could get something that was roughly symmetric. Yeah, it's unimodal, but it's also skewed. There's no way to change that. So the question was, should you proceed? And the answer to that is no, we should not proceed. All right, so there are those 2 free response questions. I hope that helps.